So the objective for the first part of this assignment is to determine whether a solution, rather a coordinate, is a solution, or if it's not a solution. So we want to see if it works within that equation. So what we do is we substitute in the x and the y value where they go in the equation and see if both sides of the equation are equal to each other. So you can see I drew an arrow to the y with the 10, so I'm going to get rid of the y and put a 10 in there. I drew an arrow to the x with the 2, from the 2 rather, so I'm putting a 2 in there. And then all I do is the math. So 10 stays 10, 4 times 2 is 8, and 8 plus 2 is 10. So that one checks out, so I write solution. Okay. I'm going to do number 4. Same idea. 10 goes in for x, negative 1 goes in for y. And I have to determine if my result, after I put those in there, is equal to 2. So I replace the x with 10. I replace the y with negative 1. And 8 times negative 1 is negative 8. And the plus negative 8 could be just turned into subtract 8. So really, we end up with this. And since 10 minus 8 is 2, and that is equal to 2, this is also a solution. So that's all you write down, whether it's a solution or it's not a solution. But you need to show the math. Show that you plugged in the values for these other 4 problems and you've checked them. If they don't work, it's not a solution. If they do work, it's a solution. When you get to these problems down here, this is what we've been practicing in class. So they give us 3 values and we have to plug them in for x. So I'm getting rid of the x and I'm replacing it with a 7 in the first example. And 7 plus 2 is 9. And so my coordinate is 7, 9. Second one, the x value is 4. 4 plus 2 is 6. So my coordinate is 4, 6. And finally 0. And 0 plus 2 is 2. So I end up with 0, 2. And then I plot them on the graph. Got to figure out how to make this small enough that I can fit everything on there. Looks like all of my points are positive. So I can kind of zoom in on quadrant 1. Okay, with quadrant 1, I'm going to go to the right 7 and up 9. And that puts me right here. Next point, I'm going to go to the right 4 and up 6. And finally, right 0 and up 2. And then because this was a linear equation, I know that that creates a line. I connect them and make sure that we put the arrows on the end. Okay, let's see if there's anything. Looks on this first page, it's pretty simple, straightforward. All you're doing is replacing the x in the first one with 3. I'm going to let you do that one on your own. I'm going to flip to the next page. Pretty straightforward, but we'll go ahead and do number 9 together. So number 9 says that I'm going to replace the x with 5. That means I'm multiplying. 2 times 5 is 10, and 10 minus 1 is 9. So my first coordinate is 5, 9. Second one, 2 times 2 is 4. And I take 1 away from that, I get 3. My second coordinate is 2, 3. Third one, 2 times 0 is 0. Take away 1, I get negative 1. And then I plot those 3 points. Again, for the most part, they're going to end up in quadrant 1. Right 5 and up 9 puts me right here. Right 2 and up 3. And right 0 and down 1. I say right 0, you could think of right or left. Just the idea is you're not moving off the y-axis, which happens to be our y-intercept. And that's the idea for these problems here on this page. Okay, so I want you to work on those on your own. Should you happen to get to this next page, these are not in the proper format. However, we can still put our x values in and solve for y. Now, because both of them have a negative sign in front of them, the 3 and the 6, I think I want to put negative values in so that we end up with a positive for the first. So I'm going to put negative 2, negative 1, and 0 in there. And then I'm going to solve for y. So I have negative 3 times negative 2 minus 6y equals 0. Negative 3 times negative 2 is positive 6. And so I've got to get rid of that 6. So I'm going to subtract it from both sides. That means it's going to wipe out here. And I'm going to have negative 6y equals negative 6. And when I divide both sides by negative 6, I get y equals positive 1. Same thing with the negative 1. Negative 3 times negative 1, is 3. Subtract 3 from both sides, I get negative 6y equals negative 3. And when I divide both sides by negative 6, I get positive 1/2. A little harder to graph that one. And then finally, negative 3 times 0 is 0. So if that's the case and I take negative 6, because this 0 is insignificant, if I take 0 and divide it by negative 6, I also get 0. Writing my coordinates. We have two good points, the top one and the bottom one, that we can plot pretty easily. So the first one says to go to the left 2 and up 1. Next one says left 1 and up 1/2. I'm going to leave that one out for now. The last one says 0, 0. Now I left that one out because it's partway in between, and so I'm going to fill in the line and leave it at that. I know that point falls at 1/2, but it's hard to find the 1/2 right there. Okay, so that's the idea. Even if it's not in the proper form, you can still graph that equation. And I'm going to check page 4. And page 4 looks like it's more of the same stuff. In this case, we are multiplying by fractions. Okay, whenever you multiply by fractions, 0 is always a good option, but anything that is a multiple of the denominator. Since the denominator is 3, I could use negative 3, I could use 0, and I could use positive 3. What that will do is clear the fraction when you multiply. And you can use your calculator to figure that out. And I'm going to stop the video there. You can go back through this as many times as you need to.